All right, this is a new topic, geometrical applications of calculus. Now, if you think back to the prelim course where we learnt how to differentiate a function, then we learnt that when you differentiate a function, it gives you the gradient of the tangent to the curve. You actually can't work out the gradient of a curve because it's curved, so you do the gradient of the tangent to the curve. So, for example, if the curve's like that, if you want to know the gradient at that point, it's the gradient of the tangent at that point. You can, for example, work out the gradient of a straight line, but, using rise over run or y2 minus y1 over x2 minus x1. But for curves, gradient of tangent to curve. So, just looking at the notation here, if y equals fx is the equation of the curve, so y is a function of x, remember the first derivative can be written as dy dx or f dashed x. That's the gradient function of the curve. It gives the gradient of the tangent to the curve at any point, the point being xy, all right? Or the gradient of the curve at any point xy. Now, dy dx, if you just think of what, for example, if you're doing the gradient of the tangent, when we learned first how to work out the gradient of a line, it's rise over run, with straight lines. And rise is the change in y, and run is the change in the x values. If you think how gradient, the equation is y2 minus y1 over x2 minus x1, gradient is actually the way that y changes with x, because it's rise over run. It's what is the change in y compared to x. So dy dx, this dy dx means rate of change of y with respect to x. Okay, now, the bigger the gradient, the more y changes compared to x. The smaller the gradient, the less that y changes with respect to x. Okay, now, if dy dx is greater than 0, that means you've got a positive gradient like that. Okay, then if I've got a positive gradient, gradient is greater than 0, gradient is positive, then gradient is positive, then it's an increasing curve. So y increases as x increases for increasing curves. And if the gradient is negative, then as x gets bigger, y gets smaller. Are we okay with that? Then it's what we call a decreasing curve. So y decreases as x increases. All right. So, and if the gradient is 0, then the gradient of the tangent to the curve is like this. That's got a 0 gradient there. It's flat. Gradient 0 means the curve is flat, okay? So the gradient of the tangent to the curve is 0, and so the tangent is horizontal, and we're calling this, you'll learn about this later, it's called a stationary point, okay? Now, a curve is monotonic increasing if it increases throughout its domain. I'll give you an example of monotonic increasing. Is this always, in other words, monotonic increasing means it always has a positive gradient, or dy dx greater than 0. That means positive gradient. Would you say, look at this curve here, is the gradient always positive? Yeah. Good. What about this curve? Is the gradient always positive? Yes, it is. Except for, yeah, it is. So they've both got positive gradients all the time, and so does that. Okay? So look, if I do tangent to curve, positive gradient, as long as my pen stays like this. Tangent to curve, positive gradient, straight line, positive gradient. So monotonic, mono means of the one type. Monotonic increasing means it's only an increasing curve. I will show you an example of something that's not monotonic increasing in a minute. And a curve is called monotonic decreasing, meaning that it always has a gradient less than 0 or a negative gradient if it, for example, looks like this. Has that always got a negative gradient? Or this? That's always got a negative gradient? Or this? That's always got a negative gradient. So can you see that? So these are all increasing. They're all as increasing curves and only increasing curves. Now, I'll give you an example of something that is not monotonic increasing or decreasing. You ready? So over here, These are not monotonic increasing. Are you okay with my arrows, or decreasing? Look at this. This curve is both what? Decreasing and increasing. Do you see? Oh, and same with this one. That's increasing and decreasing. All right. I could draw a curve like this. That's always increasing. Look at this. That's always increasing. And this always has a negative gradient. They're both. So here is another type that's increasing always, and this is always decreasing. Okay? But these are not monotonic increasing or decreasing because they've got decreasing and increasing both on the one curve. Do we get it? So parabolas, for example, are not monotonic increasing or decreasing. Just some examples here. Consider the curve with equation y equals x cubed minus 3x. You know what we're going to do as well? We're going to sketch this later because we know how to sketch it from 3 unit. All right? And it's asking for what values of x. Find the values of x for which the curve is stationary and for which it's rising. Now, if we look back up here, when dy dx is 0, the gradient of the tangent to the curve is 0, so the tangent is horizontal and the curve is what we call stationary. Okay? So let's have a look. What I'm going to do, are you ready? What do I do? What do I have to do here? Find, very good. Let's find the first derivative. So dy dx is what? If that's what y is, what's dy dx? 3x squared minus 3. Okay, we know for stationary, what does dy dx equal?
0.
Okay, so I'll just write for stationary. When the curve is stationary, I know that dy dx is 0. And so 3x squared minus 3 is 0. I'm going to have to sort of work like this in columns, okay? So what can I do here to solve this? 3 bracket. It's 3x squared minus 3 is 0 to differentiate. Bring the 3 down, x, drop the power, and derivative of 3x is 3. Do you remember that? You drop a power of the x. All right, what do I do now? How am I going to work out what x is? 3 bracket x squared minus 1 equals 0. What do I do now? 3, no, keep going.
X minus 1 and x plus 1.
Very good. Factorize. So I'm trying to solve this equation, 3x squared minus 3 equals 0. The way you solve it is you factorize it. Very good. Well, we take out 3 as a common factor, then we factorize, and now, well, obviously 3 doesn't equal 0, so x minus 1 is 0 or x plus 1 is 0, so we get x is 1 or negative 1. So therefore, the values of x for which the curve is stationary, do you get it? It's telling us up here the curve will be stationary when dy dx is 0. So the values, so therefore, curve is stationary when x is 1 or negative 1. Now, I'm going to show you, once we sketch this a bit later, you're going to see. Now, part 2, curve is rising. What do you think rising means? Increasing or decreasing? Curve is rising when dy dx is what? Positive, greater than 0. I know what dy dx is. It's 3x squared minus 3. So in other words, it's when 3x squared minus 3 is greater than 0. I can't, what am I going to do here? Let's do the factorized version, okay? Can I do that? So it's when 3 bracket x minus 1, x plus 1 is greater than 0. How do I solve that? First you solve equals 0, and then you see which bits are above. So how do I sketch this? Don't worry about the 3, right? I plot 1 and negative 1. Is it concave up or down? And where is this curve greater than 0? So x is less than negative 1. So here, this is where the curve sits above. So what I'm doing here, this is a quadratic because it's x squared inequality, greater than or less than sign. The way you solve these is to factorize sketch and find the region, you know what I mean, the values of x for which this curve is above the x-axis. So it's x is less than -1, x is greater than 1. So therefore, that's when the curve is rising. Curve is rising when x is less than -1, x is greater than +1. Now, you know what I'm going to do? I'm going to try and just go back to the original curve and sketch it. I'm just going to need a bit of room. So that's finished there. I'm going to do a quick sketch of the curve in this space here. Look, we know how to sketch this, y equals x cubed minus 3x. So I'm going to just say sketch y equals x cubed minus 3x. How would I sketch it? I'm going to take out an x. What do I get? X squared minus 3. Factorize that. If it was x squared minus 4, you'd put x plus 2, x minus 2, right? If it's, actually, I'm probably not going to be able to do this. You know what? I might show you on Desmos because you're not going to be able to see where it turns. You're not going to be able to see it. So I'm going to sketch this on Desmos so you can see where the curve is stationary at x is 1 or -1, and you're going to see where the curve is rising for values of x less than -1 and x greater than 1. So I'm going to do that now. This is where the curve is stationary when x is -1. See how the gradient would be this line here, the tangent to the curve. Positive or negative, the gradient of the tangent here, positive or negative. So wasn't our answer that the curve is rising for values of x less than -1? Does that make sense to you? Tell me about here. The tangent is horizontal. So the curve is what we call stationary. Also down here at 1, when x is 1, the curve, the gradient of the tangent is 0, so it's stationary. Tell me about between -1 and 1. Tell me about the gradient. Negative. That's why that wasn't our answer. But tell me about when x is greater than 1, the curve has a positive gradient, so it's rising. Okay? That's how that ties in with our answers. Determine the domain, which is the values of x. Remember domain and range? The values of x for which that function, which is x cubed plus 9x squared minus 21x plus 11, is decreasing. So we know that for decreasing curves, the first derivative is less than 0. So what have we got to do first? F dashed x. What does that equal?
3x squared.
Yep, 3x squared plus,
18x
very good,
minus 1.
good. Now we know for, I'm just going to go decreasing curves, we know that dy dx or f dashed x is less than 0. So because we're using f dashed x here, function of x, we use f dashed x as our notation. So we need to put, so therefore 3x squared plus 18x minus 21 has to be less than 0. What do you think? We're going to factorize this, but what can you do to simplify things a lot before you start? Fantastic. Divide everything by 3. We've got x squared plus 6x minus 7. All right, so we're going to factorize. Two numbers that multiply to give -7 but add up to give +6 would have to be x plus 7, x minus 1. We know that, so we're going to cut it -7 and +1. So therefore, is it concave up or down this curve? So we draw it like that. And where is this curve less than 0? Yeah. So it's between -7 is less than x, which is less than 1. There's no less than or equal to's. It's less than x. Okay, I'm going to sketch this function in Desmos. So what we're going to specifically look for is the values of x between -7 and 1, and that curve should have a negative gradient for those values. Completed a sketch in Desmos. I've had to change the scale quite drastically. So I've spread out the x, and this is the y-axis, because the maximum here is at 260 or something. So notice from the values of x is -7 to the value of x being +1, the gradient here is negative. See, when x is greater than 1, the gradient's positive. Look, when x is less than -7, the gradient's sorry, here the gradient's negative. For values of x less than -7, the gradient is positive. For values of x greater than 1, the gradient's positive. Do you get it? And when x is -7, looks like we've got a horizontal gradient. And when x is +1, horizontal gradient. Question 3, show that the tangent to that curve, which is the same curve again, at the point 1, 0 is parallel to the x-axis. Okay? So if it's parallel to the x-axis, here's the y-axis, here's the x-axis. If something's parallel to the x-axis, it's got a horizontal gradient. So if tangent is parallel to the x-axis, then the tangent is horizontal. So this occurs, which occurs when dy dx is the gradient 0. So the tangent's horizontal, in other words, it's flat. So this occurs when dy dx is 0. So we know when dy dx, or I should have put f dash x in this case, so it doesn't matter. Actually, I'll just put dy dx because it's y equals, okay? So therefore, we know that dy dx, in our case, it's the same function as before, is 3x squared plus 18x minus 21. And we're going to put it equal 0. Remember, we divided through by 8. It's the same curve as before. Remember, we got, when we factorized it before, you don't have to rewrite it out. This occurs when x is -7 or 1. So it says, show that the tangent to the curve is parallel to the x-axis at the point 1, 0. I've only shown that it occurs when x is 1. What should I do now? So when x is 1, what does y equal? Where would I find out what y equals when x is 1? Sub it into the equation. So when x is 1, and you sub it into the original equation of y, not into the derivative equation. So when x is 1, y is 1 cubed plus 9 times 1 squared minus 21 times 1 plus 11, which is 1 plus 9 minus 21 plus 11. Because it's saying show, you've got to show all the working. So 1 plus 9 plus 11, well, that equals 0. 1 plus 9 plus 11 is 21 minus 21. I just did the positive ones first, which is 0. Therefore, we've got the point 1, 0. When x is 1, y is 0. So therefore, tangent to curve at 1, 0 is horizontal. This is now from chapter 2 of the HSC text, Geometrical Applications of Calculus. Just what we've gone through today. You'll just notice positive, negative gradient, 0 gradient. Here, that's all positive, gradient 0, gradients negative, gradient 0, gradients positive, etc. Okay? So just look through those. We've spoken about that negative gradient, 0 gradient down here, positive gradient there. We spoke about this. It was on your other sheet. If the first derivative is positive, the curve's increasing. First derivative negative, curve is decreasing. And stationary if the first derivative is 0. So if you can, for homework, and we've just done examples like this, okay? So could you please, in the homework, do question 1 from exercise 2.1? And then we might just do something like, I think I'll email you with what the homework will be. Okay? I'll email you.